I'm making this video to show you how to use unit testing and how to work with a model. Uh, Here I have a simple application. It's basically what we call components on our project, but it's actually the entire application because we have all the necessary parts for one Mercury application. Here we have render functions, we have our model, and we have our channels. I'll start this from scratch. So as you can see, we don't have any methods in our channels, and we have a simplest state with counter value equals to 0. Uh, when I'm saying components, this is what I'm thinking about. I refer to these render functions. Those are actual components. Model and channels are actually the controller part of this application, and that's what controls the state of our application. That's why I'm talking about these render functions as actual components. So here we have a simple layout. This main render function actually renders the entire layout of this application, and this partial here renders this component, which renders only this number, this dynamic part of our application. So basically, when we work with front-end part, with the rendering part and writing actual components, we don't have to care too much about dynamic state and channels. We can simply hard code our model. This is our actual application state, and it's good thing to enter add any property that is required for rendering this state inside this model. So for example, if you want to add something else, I don't know, we'll add something later. For this video, it's good everything to be present in this model, because that's what describes our actual state of the application. So how we used to do this is, as you already know, for example, we want to add click handler on this box, and each time we click on this box, we want to increment this field. While developing the view, we don't really have to care about that, but we will just log our action in our controller. So let's for starters, let me set up just this indentation. Increment channel, and for this part we can simply use logger and log our action. That's all we need for this part of development. We do this as you are used to it. Nothing new here. So we are just going to add that handler here. And now each time we click on the box, we'll have just logger telling us that something happened. Let's see what's happening now. Oh yeah. Mistyped. Anyway, what's important, how to handle when we are working with actual controller. For that's what I wanted to show you now. I'm going to add mockup, gulp mockup, gulp YouTube, and I like to use expect.js library for writing our unit tests, and I'll show you how to do that, and I'll show you why that's important. Okay. Something with gold watch is not alright. Okay, so I've installed, and I'm going to add a new file. First I'm going to uncomment these things in our code file. So basically we are adding new tasks. Test for watching test, we can put it inside the test directory, and we are adding watch to watch all the JS files in case so that we don't have to run manually test each time. So now we are going to set up our test suite. There's a couple of things we need first. Here's first thing is expect. From expect library. So we are going to put it inside our test directory. Okay, and we are going to need, of course, mercury, hg, and we are going to set up our test suite. Basically, we are describing all the actions in our application. So let's call it counter application. And here's how we are going to do with our model. First, we want to include our initial state from our model. And it's located inside browser demo model.js. That's our initial state. Think of it of the model.js as of initial state of your application. That's initial state that is passed to the render method in order to render the view. So that's our beginning state, our initial state. And we need, of course, our channels. Which are also in the same directory. When setting up suite, it's we can, since we work with observables, we have to define our observable, and there's before each we are going to instantiate new we are going to set our observable to initial state. So for each test we are going to start with initial state. We can do that manually differently if for the purpose of the test, but in most cases we want to start with initial state. So observable is going to be value of init state. So this method will run before each tests and set up our suite. And after each we can of course destroy or reset our state, but for this test we don't need that. And now we are going to describe our first action, increment. But how to do that? In order to compare new state with we have to pass a listener to the observable for each change. So we actually pass the function which will receive the new state each time observable set is invoked. So each time something changes, this function will be invoked, called, with the new state, with the new value of the observable. And that's where we are going to put our assertions about the new state. So since we are testing increment method, increment channel, we expect that new state counter to equal 1. We can, for example, we now can first assert that initial state counter equal 0. Let's test that first. That's our first assumption. Our first assumption is that initial state counter is equal to 0. And let's run test now. Actually, I'm gonna start watcher on our test. So each time we make some changes to our test or any other test is going to run again. Okay. So we need to use strict mode Okay, so what we needed here is actually const, but never mind that. What's happening now? Our test is failing. So our observable is not okay. Anyway, I don't know why this is not working. I'll deal with that later, but for purpose of this test we don't have to set up okay. This works now. Our first expectation is passing, so our initial state counter is equal to 0, and now we need to invoke our channel with the observable to increment the value of the counter. So is we have our reference now. Now the test is failing. That this is expected because our channel is actually not doing anything. And now only now is a good time to start implementing. First we set up our test, then we satisfy what we expect. So it's usually better to do that way than the other way around. You'll get used to it. It takes some time, but after a while you realize that that's the better way to do it. So now what we have here, we accept observable as an argument, and we need to get the value of the observable, which is our initial state. Then we are going to increment the counter, and then set new model, new state as the observable value. So so what's happening? And now finally our as you can see, as illustrated, this is why it is good thing to have test set up before you start implementing the actual logic into your application. Each change you make, Watcher will run test again and alert you of any errors or mistakes you've made. So basically we now have our application logic tested and in place. So now we can expect that this counter is going to work. This is nice. But what about immutability? Why? And that's another reason why I'm making this video. Immutability is very important concept, and it's important to always return a new state once the state is passed to the channel. We expect that channel is going to return new state, and I'll illustrate that later. First, we can set up another expectation here, that all actually init state is not equal to new state. That's what we expect, but what is actually happening? Our test fails because what is happening? Our initial state and our new state, although the property is mutated, we are actually mutating this initial state, but it's still essentially the same object, and that's why the init state is still equal to new state. So how we can fix this? We can actually create here new object and then assign the value of the observable, our initial state. So we are actually assigning all the properties of the initial state to the new object, new state. And now both of our expectations are true. And that seemed quite easy. Another way to do this is to freeze our initial state. We can use object freeze of the initial state before we pass it as a value to the observable. But I'll explain later why object freeze is not good, because it freezes only the root object of our state is freezed. So the root object cannot be mutated itself, but his children can be. And here's how I'm going to illustrate this. For example, if we want to add another component here, history. We want to log history of our counter. So we want to keep track of each incremented value. We are going to make a simple list. And we are going to render that history here. So we are going to need what I was talking at first. We are going to add history as a property to our initial state, and as initial state is going to be just an empty array. And what we want to happen, we want in our test, we expect that, and we are going to write it here, we are going to expect now that new state history but last index of this array is going to be equal to let's say init state, no, actually so it's going to be equal to, and our test is failing because we didn't implement it yet. So we are expecting that last index of this array, history array in the state, is going to hold the value of the counter. So what we are actually going to do here is to push the counter value into this array, and our test is passing. Our test says it's okay, that's good. So we have, but this is what is happening, nothing is rendered. That's what I'm saying. That's where the immutability is important. What's happening here, that we are actually mutating the history property. We are calling the push method of the array, which actually mutates that array, adding new value, but the array is all the same. We could try this, but that won't make any difference. This won't make any difference. In fact, this is since the push method of the array have no return value, we are effectively destroying the property of the history. So we are actually not doing anything. What is best thing to do is to use concat method of the array, because concat method actually returns the new array. What's happening now? How we cannot call this age, but call it I for the IT. And now our history works. There's another method, another thing we could use, and it's highly recommended, is to use the deep freeze library. And I'll illustrate how to do that. We are going to add it to our project as dev dependency. And we are actually not going to freeze the object, but we are going to deep freeze initial state. But notice we are doing this only inside our test. So only when we are passing our state inside of the test, we are going to deep freeze it for the purpose of development. Once in the real-time application, this state is not going to be deeply frozen, and it's going to be editable as usual. But for the purpose of development, this is a good approach. So I'm going to start test again. Test will probably pass this time, but here we are going to use strict again, so that each time we try to mutate the deep freezed object, for example, if we are not doing this, we'll have type error that says cannot assign to read only property counter, and that's all thanks to this deep freeze object. And that's what I recommend while developing. While in the same thing will happen, for example, if we try to mutate any of its child. For example, push is mutating model method. So if we want to mutate it using push, we'll also have type error, can't add property 0, object is not extensible. And that's why I recommend using deep freeze and using unit tests to test our application. And this is basically the way to do it. I'm not sure why I cannot declare in before each. But that's probably I'll probably come up with a solution quickly enough. But for now, what's important to know is that this way, for example, if you want to add another test, you will always have observable with initial state which is deeply frozen before you run each of the tests. This is probably because I'm writing ES6 notation, but yeah, something about block scope declaration, light constant. But I'll come up with solution for that. You could use, of course, you can use a ES5, or actually you can use bar, but this is enough. This is good for this is how you are skipping the tests. And in general, that's the whole point of this. So using deep freeze, using Mocha for tests, and writing tests before we add logic to our channels is the best way to make sure that each time we make changes to our application, we have everything covered, and all tests are passing or failing, and we can easily find what is the problem here. Thank you.